Good morning. How are we doing today?
Good.
Good? Okay, great. A little sparse this morning. Maybe I'm earlier than usual. Maybe that's it. I don't know. That could be it. I never know. So, we want to talk today a little bit more about that law of sines, and we want to talk about the law of cosines today also. So when the law of sines doesn't work, we're going to resort to the law of cosines for our oblique triangles. So first off, do you remember what oblique triangles were? Remember what those were? What does it mean for a triangle to be oblique? It's not right. Right. There's no right angle in it, so it's an oblique triangle. So let's go back just a minute to what you were working on section 8.2. You all were trying some of these law of sines problems, and let's just kind of refresh our memory about at least one of those for a minute, and then we'll see about that law of cosines as well. I want to remind you again that we're having a test a week from Thursday. Okay, so over some of this material as well as a little bit more, so I'll give you more details then on Thursday, okay, about that. And but let's go back to page 524 and 525 this morning. Okay. Does anybody have one there that you tried that you'd like to look at?
You do 41.
So 41's one of the ones I gave you that one. There's one on, I think, quiz 9, quiz 10, somewhere in there that's similar to this also on the My Math Lab. Speaking of My Math Lab, you don't want to forget about that stuff. Okay, this is a good time if you haven't started, and I know that's nobody in here, but that was a joke actually. But if you have not started, it's a good time to start working on it because you'll want to make sure you have time to finish. There's only 11 quizzes right now. I noticed in yesterday's class, quiz 11 was not showing up yet, which we haven't covered that material yet. I haven't assigned that one yet, but I'll have to look and see where that one is. Yes?
What quizzes are over the material we're doing right now?
Right now, you should be able to do quiz 9 just has, I think, 5 questions, and it's over section 8.1, the right triangle trig. And then quiz 10 has questions from sections 8.2 and 8.3. So after today, you should be able to work on quiz 10, okay? All right, so we are winding down with those a little bit there. We're getting toward the end. So if you have not started those, again, you'll want to start those so you will have plenty of time to get the grade you want. Now, all this was laid out on the syllabus. I know that's been a couple of months ago, but the syllabus, remember, is always posted on D2L for your convenience. But remember that the My Math Lab quiz average also counts the same as one of your test grades. You want to do that, okay? You want to do that. You can do really well with that. You have infinite tries on each quiz. You should get a good average on that, is what I'm telling you, okay? Any questions about the My Math Lab stuff? Yeah.
So it would be the average of your last highest grade, right?
It takes the highest grade per quiz and averages those. And then that, along with, I will throw in with that your unit circle quiz we had and that homework assignment we had that you did out of class, okay? So I'll throw those 2 things in as well. Yes? I'm sorry? Who's going? Go ahead, Brandon.
Well, those 2 tests that we took, we counted into our math lab?
They'll go in with the My Math Lab, right? Okay, go ahead. Okay, so yeah, the 2 things we did in class or outside of class, they will go along in with those, just like 2 more quizzes, Math Lab quizzes, okay? So that's how they're going to count. All right, I know we get more and more questions when we get to this part of the semester about things like that because we don't have as much time left. Actually, today, let's see, today's November 11th, and we said your all's final exam is on December 9th. So we're now less than a month, right? Ooh, we didn't want to think about that this morning. All right, let's do number 41 over here on page 524 and 525. Or actually, it's on 525. It's a word problem. It says finding the height of an airplane. An aircraft is spotted by 2 observers who are 1,000 feet apart. As the airplane passes over the line joining them, each observer takes a sighting of the angle of elevation to the plane as indicated in the figure. How high is the airplane? So we have a figure here. I'm going to put it up here on the screen. Well, just my version of it. An angle of elevation is what you have when you're looking up towards something. So the angle of elevation that they're showing here, for example, here's the distance apart, was 1,000 feet. And they're both looking up to this airplane up here. I will not draw it. I'll just write airplane. Okay, I'll spare you this morning. And so we have observers here. So we have person A here. I lied. I'm drawing stick people now. Okay. And they're both looking up at the airplane. So this right here is the angle of elevation for this one. It's 40 degrees. Over here we have an angle of elevation, it says, of 35 degrees. We have just this perpendicular line drawn up straight up to the airplane. They're just showing from the ground straight up to the airplane. They don't have the little 90-degree drawn in, but we're seeing that straight above, wherever that airplane would be perpendicular to the ground. We're assuming the ground is level there, okay, by the drawing. All right, so as the airplane passes over the line, join them, each observer takes a sighting, okay, and how high up is the airplane? Because this is what we want to know, this height right there. That's what we're looking for. How high up is that? Well, here's one thing we cannot assume. We cannot assume that it's 500 feet on both sides there on the bottom. Okay, we cannot assume that. It's tempting, but we can't. What can we do here? Anybody have a suggestion? I'll take suggestions.
Well, we get the third angle on both triangles, first of all, which would be 55 on the right triangle and 50 on the left one.
Okay, so you got those angles because we see we've got, if we look at it as two separate right triangles, we know that the angles inside the triangles have to add up to 180 degrees. And so we're going to add those up in order, or find the missing angle there. Now, with that in mind, what can we do now? I just want you to think about it. Tell me. Okay, we can find what? Which side? Okay, which one you want me to find? Here, I'll label them. We'll call this one A, right? I'm just randomly labeling since I didn't have angles labeled, okay? Which side do you want us to find? H? Okay, how are we going to find H?
Can we not use our angles to find H?
Well, tell me how. Be more specific, okay? We're in the section on Law of Sines, so I'm thinking they're going to want me to do something with Law of Sines, even though I'm seeing little right triangles here. But Law of Sines, what can I do here?
The sine of 50 over 1,000 feet.
I can't do the sine of 50 over 1,000 feet because 50 is just across from this piece here, right? I could do the sine of 105 degrees over 1,000 feet. I could do that, okay, with the law of sines. I could say the sine of taking this whole angle there, that over 1,000 feet equals what?
We can do 35 degrees over B.
Sine of 35 degrees over B. In other words, we're looking at the large triangle right now, right? We're looking at the large triangle. Okay, well, that's going to give us side B. Side B would also be the hypotenuse of that little triangle on the left. If we knew that, that would help us find H, wouldn't it? If we knew that. So I think we can work with that part here. So B sine 105 degrees, we're cross multiplying now, equals 1,000 times the sine of 35 degrees. Looks like then B equals 1,000 sine 35 degrees over the sine of 105 degrees, which is approximately equal to I'll let you tell me. Somebody have it?
593.81.
Okay, 593.81. We agree? We got some agreement going on, yeah. Okay. So 593.81. So what can I do with that to find h? Remember, h is what I was calling this distance I want right there, that vertical distance. I could use some right triangle trigonometry, couldn't I now? Like some opposite over hypotenuse or something, maybe? Which one's opposite over hypotenuse? Yeah, so I could do the sine of 40 degrees, it looks like, equals the opposite side over the hypotenuse. And we'd multiply both sides by the 593.81. What does that give us? 381.69 feet. Then would be how, whenever they're looking at the airplane with those angles of elevation, that's how high the airplane is at that time. The height of the airplane we think of as a vertical distance, so it's perpendicular to the ground. That's what we would do with that one. I'm pretty sure there's something similar to that on one of the My Math Lab problems. Any questions anywhere within the problem? I'd like for us to look back at another one of the ones up above the word problems, the 25 to 35, just to make sure we're seeing if there's 0, 1, or 2 triangles. I think we ought to check back on that for just a moment. So did anybody have one there you want us to look at? Or
25.
25's good?
Yeah, that's where I start running into problems.
What's that?
That's where I start running into problems.
That's where you started having problems. Okay. That was the first one in those directions.
Yeah, I got it all done except for, like, I got it down to the you got the signs equaling 0.93, and then it's like, after that, I'm like, I don't remember how to do this, and I couldn't make it out of the notes already.
Okay. Here's what we've got. Side A is 3, B is 2, angle A is 50 degrees. Okay. So we have A, B, C, and A, B, C. And let's label what we know. A is 3, B is 2, angle A is 50 degrees. Okay, that's what we know there. We notice that we have side-side angle, or as we also called it, angle side-side, the asked case, right? Now, in the directions, they told you to look for 0, 1, or 2 triangles, but we know just if we're not in the textbook land where we're in section 8.2 and we know to look for this, we're going to see we have angle side-side. We only have one angle given. That's what makes this ambiguous here. We only have one angle. Okay, we've got the other two sides, the measures, but that leaves us 2 angles to kind of mess around with and see, what. I mean, they could be different values, right? And still form a triangle. Or there could maybe just be one thing that works, or maybe it doesn't work at all, the information they give us. So that's what we're looking at here with this ambiguous case. It only happens when we're given that one angle, one angle and side like that. Whenever we already are given 2 angles, we don't have a choice what the third angle will be. It has to be what it has to be to make 180 degrees. Here we have a little bit more choice between our other angles. So what we're going to do, though, is we're going to start out looking. We notice that we don't know it's a right triangle, so we can't go with that. But we do see that we have an angle and the side across from it. That's what tells us to use that law of sines here. It's not a right triangle. We know an angle and the side across. So we're going to start with that sine of 50 degrees over the side across from it, 3, equals, and which one do I have to use? B. sine of B over side B. I don't have a choice. I'm going to be finding angle B. So I have 3 sine B equals 2 sine 50 degrees. Okay. To get sine B, then I have to divide by 3. 2 sine 50 degrees divided by 3. And remember, to get an angle, you always have to end up doing an inverse trig function. So we're going to do the inverse sine of 2 sine 50 degrees over 3. And that tells us that angle B is approximately equal to what?
112.19.
112.19. Okay, thank you. 112.19 degrees for angle B. Okay. So remember back here at the beginning, we're wondering, is this going to be 0, 1, or 2 triangles? Right now, we can exclude the 0 because we got a value out of this. We got an angle B. So we know we're going to have at least one triangle. That makes sense, right? We got a value for B. The question now then would be, are we just going to have this one triangle where B is equal to 112.19 degrees? Or is there going to be some other possibility? To check for that, we want to look at the supplement of angle B. Because we established last time the sine of an angle and the sine of its supplement are equal to each other. Supplementary angles, remember, add up to 180 degrees. So now we're going to check for possibility of second triangle. To do that, I'm going to take 180 degrees minus the angle I just found, which gives me what?
67.81 degrees.
Okay, 67.81 degrees. So my question here would be, can B, the one I just found, it still has to be the angle I just found, can B equal 67.81 degrees? So I look back up at my triangle, at what I was given up there. I have one angle that's 50 degrees. Sure, B could be 67.81 degrees because I can still put the rest of it on angle C, right? See what I'm saying there? I can still have a triangle if angle B is equal to 67.81 degrees.
Does that ratio between angle and side matter?
What do you mean?
Like,
Answer.
isn't it smaller angle against smaller side?
Right, we still have the smaller angle will be across from the smaller side. And so,
Greater than A.
oh, that's interesting, isn't it? Did we just find that? What's that?
I got 30.7 for that angle.
When you first did it? Yeah, B couldn't be 112.19 degrees. That's a good observation up there. So what is B then? After you all waited till I found all this. What is B? So you're saying back up here, yeah, it can't be 112.19. You're right. So what's it going to be? Weber? All right, say that again.
30.71.
Angle B, 30. Yeah, I didn't look at that ratio there. You're right. I should have checked that out. I trusted you guys. So, all right. So if angle A, what they're saying here is angle A was 50 degrees, right? The side across from angle A was 3. I didn't double check that. I should have noticed that that ratio wasn't in accordance with what we've talked about. Angle B has to be smaller than angle A. It must be because side B is smaller than side A, okay? So those ratios have to hold. So angle B then must be 30.71 degrees. Okay, I hope that doesn't throw anybody off too much there. 30.71 degrees. Now I just put that in, so let me write it in red because that was not given to us. And down here then we're going to take 180 minus 30.71 degrees. So what's that equal? Okay, or 29. So can B equal 149.29 degrees? Can B equal that? Okay, so now we've got a new scenario here, right? Because what we've got, remember what we've got given to us? Here's what we had. A was 3, B was 2, angle A was 50 degrees, right? Now we're saying can B equal 149.29 degrees? And the answer is no. Why not?
Because B is bigger, 2 is smaller than 3.
All right, we got several reasons, okay? Yeah, the thing I noticed first is that these two angles add up to more than 180 degrees. You see that they're adding up to more than 180 degrees. So how am I going to get a triangle out of that? How am I going to get a third angle? 50 plus 149.29 is 199.29 degrees. I'm way over what the angles in a triangle can equal, and I haven't even put in anything for angle C. So B cannot equal this. On the one we were looking at before, when I didn't pay attention to the first one we got, okay, that one was going to work. But here, when we look back and say, hey, our sides and angles have to be in accordance to each other here. All right, so we're only going to have one triangle on this one. That's what that's telling us. There's not that second possibility because the value we got for the supplement of the angle we first found is too big when it's placed with the angle A that we were already given up there at the top. So we'll just finish solving the triangle we have up here. And to finish solving it, well, we see that 50 plus 30.71 is 80.71 degrees. And we'll need to subtract that from 180 degrees to get angle C. So angle C is going to be, what now? Oh, I have to think here. Yeah, what'd you say? Yeah, 99.29 degrees down there for angle C. And we've got to still find side C. How do we find side C? Law of sines still works, right? So sine 50 degrees over 3 equals the sine of 99.29 degrees over C. Find side C for me. I'm running out of space here.
3.86.
3.86. Okay. Well, side C does have to be larger than the other two sides. We see that much, right? I'm going to watch that stuff more up here now. Do we agree with 3.86? Several of you punching it in. Y'all trust each other? All right. Some of you say, what am I punching in? Well, here's what you're punching in. 3 times sine 99.29 degrees divided by that sine of 50 degrees. That's what's ending up happening, right? The ones where we have both of them are getting multiplied, divide by that other one. So we agree 3.86. Okay, good. Questions here on this one. Are we seeing how to tell if there's actually going to be one or two triangles? 0 is a little bit easier to tell because if it's going to be no triangles, then if nothing else, when you start working out the formula, you're going to get error on your calculator. It's not going to work out for you. And that tells you no triangles. Yes?
Anyone that has more than one triangle?
I'll try to find one here. So. Okay, we did one last class that I knew about, but let's see. I might have to look back here and see.
31.
All right, so we'll go with 31 then. So let's draw it. B is 4, C is 6, angle B is 20 degrees. We're still with angle side, side. It's an ambiguous case. We want to know if there's 0, 1, or 2 triangles. We start using the law of sines to start telling us some information here. So we'll have the sine of 20 degrees over 4 is equal to the sine of angle C over 6. So this time we have to find that angle C first. So 4 sine C equals 6 sine 20 degrees. And the sine of C is 6 sine 20 degrees divided by 4. And C will equal the inverse sine of 6 sine 20 degrees divided by 4. Now let's see what you all get for that one. This time we're going to look ahead just a little bit and say, angle C, how's angle C going to compare to angle B? If you're not doing your calculator, you can tell me that. How's angle C going to compare to angle B? Yeah, it's got to be larger than angle B because the side across from it is larger than side B. What do we get here?
I got 30.87.
30.87. Well, that's larger. This way I want to make sure we got verification here before we go on this one. Okay, since I'm not punching it in up here. 30.86. That's not too far apart from each other. So it's 0.87. Okay. Everybody agree? Everybody, several of you have punched it in your calculator, right? Not trusting your neighbor anymore. Okay. All right, so 30.87. So that tells us it's not going to be the 0. We'll take that one off. That's not a choice now. It's either 1 or 2. So let's see, before I even write it up in there, let's go ahead and see if angle C can equal the supplement. So that's what we're looking at now. Can C equal 180 degrees minus 30.87, whatever we get from that? What do we get from that?
Yeah, 149.13.
Okay. So can C equal 149.13 degrees? If angle B has to be 20 degrees. It can. It can, because 149.13 degrees for angle C plus angle B being 20 degrees. 20 and 149.13 is 169.13 degrees. We still have space to get in the third angle. Okay, so the answer there is yes. So that tells us we're going to have 2 triangles. Okay. So in our first triangle, we'll keep angle C being 30.87 degrees like we first found. But we're also going to have a second triangle in which we're still given the same information. That was the information we were given. But in this second triangle, angle C is going to be 149.13 degrees. Okay. And we're going to solve both of these. So just do one at a time. Don't get yourself too overboard on these, trying to work them both out at the same time. But let's look at one at a time. And up here on the first one, the top one, what's angle A going to equal? You're going to have to add up the 2 you have, subtract them from 180. All right, 129.13 degrees up there in that triangle. All right, so still working with the top triangle. All we have left to find up there is side A, and we're going to use where we just found that 129.13 degrees. We'll also go back to the law of sines here and say sine 20 degrees over 4 is equal to the sine of 129.13 degrees over A. We're going to cross multiply. Take 4 times the sine of 129.13. and divide by that sine of 20. What do we get for A? 9.07. Okay. Side A has to be larger than the other two sides due to those angle measures that we're looking at there. Does everybody agree 9.07? Okay. So that's one of the triangles solved. And now we'll come down and do the same types of things for the second triangle to finish solving it here. So in the second one, we want to find angle A here. What's it going to be?
$10.87.
10.87 degrees, right? And then side A, we're going to have, again, I'll just go with the sine of 20 degrees over 4 is equal to the sine of 10.87 degrees over A. So we've got A is equal to 4 sine 10.87 degrees divided by the sine of 20 degrees. 2 point what? Okay, 2.205. We'll just say 2.21 there. It has to be the smallest side in this triangle. Remember, none of my drawings are drawn to scale. You can see that pretty easily up here, especially when you look at angles like 149.13 degrees. That wouldn't look like that. Not at all. Okay. I'm just drawing a diagram of a triangle for us to use to see where the pieces are. So this was a two triangle deal, and we've solved, by solving the triangle, remember, we found all the missing sides and all the missing angles today. Any questions on that? All right, so what happens if we have those other oblique triangles where we know maybe side, angle, side? We know two sides and the angle in between them is what we're saying. Okay? Or we know all three sides, but no angles. Remember, to use the law of sines, we have to have an angle in the side across from it, so we have to resort to the law of cosines in those cases. Is everyone finished with this number 31 up here on the screen? Anything else about 31? All right, let's go over here then. If we're given side, angle, side, that's what we know. Then we do not have an angle on the side across from it. You see that in my drawing here? Or if we're given side, 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 we no longer know an angle and the side across from that angle. So we have to go, we said, with section 8.3, law of cosines, for these oblique triangles. Remember, they're still oblique. They're not right. Okay. All right, so the law of cosines, it's more formulas here. That's what we have for this. And so the key formula for the law of cosines, it's going to start out looking like your Pythagorean theorem. Okay, we're going to rearrange it just a little bit, but we're going to say c squared is equal to a squared plus b squared. That's the Pythagorean theorem, isn't it? Yeah. And then though we're going to subtract 2 times a times b, so those two that were over on the right side, 2 times the product of those sides, times the cosine of angle C. That's what we're doing there. Each time what we're doing, we can rewrite this based on whichever sides we're given or what we're missing here. But each time we're going to start out with what looks like the Pythagorean theorem overall. Okay, we might rearrange these things, but depending on what we're given. But we have c squared equals a squared plus b squared. But then minus, it's always minus 2 times these two times the cosine of the one that goes with that out there. Okay, that's what it looks like for us up here. So we could plug in what we know. Let's think about here for a minute what we know on this first one, side, angle, side. We have 2 sides and an angle. Okay, So let's say we have side A, B. Here's what we've got on my triangle. Do you see how those would fit in the formula? C is the one I'm looking for. Okay. I already know these that are marked here. So I would put in a squared plus b squared minus 2ab, I already know those, times the cosine of angle C. Now what if I'm given the three sides? Well, that one I'd have to put in all three sides. You know, I'd know these things, but I wouldn't know the angle. I could solve for the angle, though. I could do the algebra and solve for the angle. Okay. Maybe a little tougher on that part. If it's not, if we don't like the way the formula is written like this, they do give alternate ways of writing it, like if you're looking for something to do with side B, side A, things like that. We just twist it around here a little bit and say, well, b squared then would equal the other two squared, a squared plus c squared. This is just a rewrite of the formula using different sides, putting it in different sides. Minus 2ac cosine of angle B. And likewise, a squared then would equal what?
B squared plus c squared.
B squared plus c squared minus 2 BC cosine A. We could write it in any of those forms. Okay. In the textbook, they even go a little further and they tell you over on page 529, these things right here are actually on 528, but on 529 they tell you the law of cosines here. It says the square of one side of a triangle, equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. That's what we're saying up here. Okay, that's what we're saying. That makes me think of, when I read that, that makes me think of in The Wizard of Oz, after the Scarecrow gets his brain, he states something. Do y'all remember that? And he's really stating, I think, the Pythagorean theorem, but it's a little bit off. Listen to that sometime if you ever watch The Wizard of Oz, okay? So it's been a while since I've seen it, so I can't remember what he says, but I remember it was a little bit off from the Pythagorean theorem. But he got his brain, okay? So let's see if we can fill this in on one of the triangles and work with the formula for a side angle side and a side side. See how that's going to work out for us, okay? Let's go over here to an example off of page 532. I'm going to use number 10 starting off. Looks like this. They've got it labeled for us. And this is what we're given. That angle right there is 30 degrees. They didn't tell us, but we know that's angle A. Side C is 4. Side B is 3. That's what we know. We're still solving triangles. That's what we're doing, okay? Solve the triangle. That's all we've done in Chapter 8, pretty much. Oh, we did do the complementary angle theorem, didn't we? Solve the triangle here. So we see that we know side, angle, side. What we do not know, here's what we don't know. Here's how we know to go with the law of cosines. We don't have a right angle. So we're not going to use right triangle trigonometry, right? That one's out. We do not know an angle in the side across from it. So we're not going to use the law of sines. So now we come to the law of cosines. All right, so which side would it make sense for me to find here? Well, the missing one, side A, right? I can't find the angles just yet because, what's that? Yeah, I need my sides, and my angles here are going to be a little tougher for me to find at first here. So let's go ahead and find side A. So that means I want to go to this formula. A squared equals B squared plus C squared minus 2BC cosine of A. Because I'm looking for side A, I will go with that version of the formula. Okay. All right, so let's plug in what we know. A squared equals 3 squared plus 4 squared minus 2 times what? 3 times 4 cosine 30 degrees. And you can get out your calculator and work that out if you want. I don't have one up here, so I'll let y'all, help me along there. But I've got 9 plus 16 minus 24. We actually know the cosine of 30 degrees. What's the cosine of 30 degrees? Yeah, square root of 3 over 2. I don't know if you're doing it on your calculator, if you want to use that or not. But if you're punching it in there, you might just punch in the cosine of 30 degrees, right? Okay. So eventually we're going to want some decimal equivalent here because it's asking us to round. So we've got a squared equals, on mine up here I've got 25 minus 12 square roots of 3 because that 2 is going to cancel into that, giving me 12 there. The 25 minus 12, remember I can't do anything with that the way I'm working up here because the 12 is included with that square root of 3 part. So a squared is equal to whatever this stuff is. You all can do that on your calculator. A squared is equal to that. What is it?
4.22.
Is that for a or a squared?
I think a squared.
A is 2.05.
Okay, so a squared was 4 point what again? 22. And then we did take the square root of both of those to get the a was 2 point, what was it, Tom? 2.05. Okay. A is 2.05 there. Okay. Now, it's going to be preferable now for us to still stick with the law of cosines, even though I'm sure you're noticing now we have an angle on the side across from it. We could resort to the law of sines, but remember we just have one angle here. So we're going to have to be careful as to which solution works, okay, because only one of the solutions are going to work in this particular case because we already have all 3 sides. There's only one solution going to work for this. But because we only have the one angle given to us when we work in that law of sines, it's going to make it a little bit back like the ambiguous case. So what we need to do, or what is preferable to do, is to go with the law of cosines. Okay, so I want you to see the law of cosines anyway where you're finding an angle here. Okay, so let's look at the law of cosines, finding an angle for one of these, either B or C. And let's go back to one of our other formulas for just a moment. Let's go back for this. C squared equals a squared plus b squared minus 2ab cosine angle C. If I were looking for angle C, for a minute, I'm just taking this out of the problem that we're working with, okay? If I'm wanting to solve for C, how would I do that in this formula? That's angle C I want to solve for, okay? Put the angle there. I'd have to do the algebra to get things to one side or the other. How am I going to work with that?
You could divide both sides by cosine C.
Don't divide yet. Okay, that's going to make it a little difficult to divide yet. Let's get rid of the things that are being added and subtracted first, okay? So I'm going to recommend here that we get rid of the a squared and b squared. We are trying to get that angle C by itself. What happens when we do this? We have c squared minus a squared minus b squared is equal to negative 2ab cosine C. Are you with me so far on the algebra? I'm trying to move things around to get that angle C by itself. Eventually I will have to get it away from that cosine part, but right now I'm just trying to get the part with angle C a little bit more isolated. So what would I do next? Divide by what? Yeah, divide by negative 2ab. Well, when I divide by negative 2ab, it gets rid of that part on the right side, just leaving me with cosine C over there. On the left, when I divide that negative through, it's going to, make the top be negative c squared plus a squared plus b squared over the 2ab if I take out that negative part. We might rather look at this part then. I don't know, maybe we'd rather look at that as a squared plus b squared minus c squared. Does that look better? Over 2ab equals the cosine of c. You wouldn't have to change it like that. But then to get c by itself, what do I need to do? The inverse cosine, right? So I'd have to say the inverse cosine of a squared plus b squared minus c squared over 2ab equals angle C. That's how we would get that part. So let's plug in the values from the problem we just had. Okay. Probably need to go back to this screen to see that. So all right, so we have C is equal to the inverse cosine of, what are we putting in? A squared plus b squared minus c squared over, whoops, yeah, I didn't need that part right there just yet, over 2 times 2.05 times 3. Let's see what you get for angle C. Y'all working that one out? What do we get there? You'll have it. Just be careful with your parentheses. Remember, you got to total up the top part of your fraction there. Total up that 2.05 squared plus 3 squared minus 4 squared before you divide by the 2 times 2.05 times 3. You got to think like a calculator. 103.15 for angle C. Well, let's see if they agree, okay? We're going to check agreement here. We agree? I'm going to double check it up here.
Yeah, I got that.
You got that? Okay, so Clay got it too, so we're looking like if we're in the right place there. We knew it had to be larger because we're across from the largest side. So everybody agree that punch that in their calculator? All right. So we'll go with that then. And then if that's 103.15 degrees, how are we going to find angle B? The old way, right? They all have to add up to 180 degrees. So we currently have 133.15 degrees. So what's angle B?
Why did you make it 133 instead of 1.3?
46.85.
I was adding the two together that we know. This one and that one. Both have to be subtracted from the 180. Okay, so I put those together. So you said 46.85 degrees for angle B. All right. The trick for if you're going to use the law of sines, let's say after we found side A there, 2.05, we found that one, and now we have an angle in the side across from it, we could use, the sine of 30 degrees over 2.05, but we would need to find the smaller of the two sides, the smaller of the two angles that's left to ensure that we're getting an acute angle, and then it should work out okay. So if you do choose to use that law of sines when you're at a point where you can, go for the smaller side, smaller angle, whichever one it is you're looking for, okay? On these, it's going to be an angle, so go for the smaller angle. And you'll know that by the sides that you have. At that point, you'll know all your sides. Go ahead.
Are we doing the 103.15 or the 133.15?
Angle C, we said, was 103.15 up here at the top. But when I'm trying to get the missing angle B, this one here, I have to subtract that one and that one from 180.
Gotcha.
Okay? Are we together there? No? That's where that came from. This was 103.15 plus the 30 degrees. That's what we were working with there. Okay. So this formula, the law of cosines formula, is a little bit more involved maybe. Definitely more involved than the law of sines formula. It's not impossible. It just uses a lot more values. You got to plug in a lot more things and be a little more careful. We're going to do another one here. I want us to do a side one also. So let me get us a side one. I have one over here. There's also a law of tangents, by the way, but it's not used anymore. So you can be thankful for that, I guess, today.
That's not used anymore.
What's that?
You said it's not used anymore.
The law of tangents. They say it's obsolete. Kind of like probably rationalizing denominators. It's not necessary. Law of tangents tells us this on page 531. Law of tangents has become obsolete. In the past, it was used in place of the law of cosines because the law of cosines was inconvenient for calculations with logarithms or slide rules, what they used to use, okay? But now, you know, where we use a calculator, it's much easier to use the law of cosines instead of the law of tangents. So we don't even look at the law of tangents anymore. So that's a plus, though, because that would have been the next section, I'm sure, in this part. Plus for you all. All right, so back on this screen a minute where we solved for angle C. Let's go back here a minute. Because maybe you're going to see this pattern as well. What if we're looking for, let's say, angle B? What do you think that's going to look like in here now? So A squared. Yeah, so see how she's adapting it to the pattern we had. We have A, B, and C in all of them, but the one that's being subtracted is the one that goes with the angle you're looking for. All right, we're adding the other two. So A squared plus B squared minus A squared plus C squared, I said it wrong, minus B squared over 2 times what? AC would give us angle B. I mean, you could go back through. You can just plug in. You can take those initial formulas that we had and just plug in your values and solve it then. You know, use your algebra with your actual numbers involved. Some of you would prefer that maybe. And then for angle A, we would have inverse cosine of what? Okay, so we're going to add the B and C parts minus the A squared over, okay, 2BC, right? Okay, so once you know one of these things, you know the others because depending on what you're looking for, they fit into a little pattern there. All right, let's go to a triangle over here on page 532. And we will look at number 16. We have 4, 4, 3. Up here's angle C, B, A. Okay, so that means this is B, this is C, that is A. We want to solve the triangle once again. Solve the triangle. All right, so we have side, side, side this time. We're missing some angles. Which angle would you like to find? Oh, what's something you notice here?
Same size.
Yeah, and I should have paid more attention, but I do want you to note that now since we've got it up here. Side A and side C are both equal to 4, so what does that mean about angle A and angle C? They're going to be equal to each other, right? So if we find one of them, we know the other. So which angle would you like to find? B? So we said B is going to be then inverse cosine. Let's see if we can remember what we do here. What do we do? A squared plus C squared minus B squared over 2AC. Okay, it's from the previous screen there. So B is equal to the inverse cosine of 4 squared plus 4 squared minus 3 squared over 2 times 4 times 4. You all got your calculators there, so. What are we getting for angle B? Okay, agree? 44.05 degrees. Okay. If B is 44.05 degrees, what are you going to do to get A and C? Yeah, on this one we can do 180 minus the one we know. Since we know those two have to be the same, we're just going to split up whatever's left over between those two. So you can take 180 minus the 44.05 in this case. What does that give you? That's your answer for the angles? Or tell me again what you said. I'm sorry.
Each would be 67.97. It was 135.
So that's what we get to split up. So I'm writing with the wrong thing. Okay. So since A and C are equal, divide 135.95 degrees by 2. So 135.95 degrees divided by 2. You told me already, what was it?
67.975.
67.98? Okay. So 67.98 degrees. Together, all those should add up to 180. Okay. That one wasn't too bad, but we can notice things like that, things about the triangles that we know about there. Let's do a word problem down here, a golfing word problem. They love golfing word problems for Law of Cosines. So, does anybody in here play golf? Anybody play golf? All right. If you don't play golf, or if you don't know about what the word problems are talking about, sometimes it's difficult to put the drawing on paper. They actually have a drawing in the book for this, but just try to listen and see if you can draw out what you think it would mean, okay? For a moment. So. This one's actually number 43 in the book. It says a golfer hits an errant tee shot that lands in the rough. All right, if you don't play golf, what does that mean?
It's off the course.
It's off the course, right. It's errant. It's not good. It's not in the right place if it's in the rough, okay? A marker in the center of the fairway is 150 yards from the center of the green. All right, so we have the green up here somewhere. We have a marker somewhere in the center. So here's what we know so far. It's 150 yards from the center of the green. That's all I know right now. While standing on the marker, okay, the golfer is on the marker now, and facing the green, the golfer turns 110 degrees toward his ball. Remember, the ball was not in the right direction, okay? So I'm standing here on the marker. I'm going to turn 110 degrees in the direction toward the ball. Okay, you can make it go whichever way, just so you go 110 degrees, okay? So in the book, they've got it drawn like this, to where that's 110 degrees. Okay. And then it says, he then paces off 35 yards to the ball. That means, you know, if he's looking toward the ball's out here somewhere. He paced off 35 yards. That means he walked 35 yards. And how far is the ball from that center of the green? So this is the part we're looking for. That's what we want. Okay, I'll call that part C. The bigger part of the word problems is getting the drawing based off the words that are being used here. Sometimes they're giving you diagrams, which is very helpful. Sometimes not. Okay, and you have to attempt to draw whatever they're talking about. There are a few of these on quiz 10 on my math lab. Okay. So I want you to be able to look at those, you know, between now and Thursday, if possible. That would be great. All right, so what are we going to do to find the distance from the ball to the green?
Law of cosines.
Yeah, we got to use the law of cosines here. Why? Because we're in section 8.3. No, because we don't know an angle and the side across from it. We see we're not in a right triangle for sure. So let's use the law of cosines. We're going to go with that initial one I put up, c squared equals a squared plus b squared minus 2ab cosine c. We're going to use that form because we're looking for what I labeled as side C there. C squared is equal to, which one are you going to call A and B, or does it really matter? It doesn't matter. We're going to just use those other two, aren't we? Now this 110 degrees has to be angle C. We see that. But we've got 150 squared plus 35 squared minus 2 times 150 times 35 cosine 110 degrees. One thing we do notice in the word problems, the numbers get a lot larger than in those triangles they were giving us. The numbers seem to get quite a bit larger. So you're going to get whatever you get for that when you're working that problem. And then you're going to take the square root of it. So after you get that, you're going to take the square root to get just C. You'll want to have a calculator next Thursday, okay? One you know how to use. What'd you get? 165.28 yards. All right. Are we in agreement there? Everybody in agreement? Were you able to get it to work out? It's a lot of stuff to punch in. All right, so if you're on your calculator, here's how I would probably do it. Even though you could put the square root in it first and put all this stuff under parentheses, it's going to get a little messy maybe. Maybe on your calculator you want to type it in like this. 150, and I don't know what kinds, we've got different calculators going on, but do some of you have a key that says x squared that you hit to square something?
Yep.
Okay. So if you've got that key, you do 150 x squared, that should square that, plus 35 x squared to square that, minus 2 times 150 times 35 times cosine. It comes up with a parenthesis. You put in your 110, close your parenthesis. Okay. And then enter all that to get a value. And then you want to do second, I guess off of the x squared key where you do the square root, right? Second square root of your answer, answer second, and there's an answer key that's over the negative on some of those. Who has that kind of calculator where it says A and S over the negative? And enter. That's taking the square root of what you already got. So this is on a TI. What kind is that does it this way?
TI 84 plus.
Okay, so TI-84, about any kind of TI-84 should do that way. TI-83 probably does it this way, I'm guessing. TI-89 might do it this way also. Now, what other calculators are we looking at? Scientific? We got some scientific. Does yours punch in pretty much like this, though? Does it? Okay. There will be some of you, though, that will have to do some things a little bit backwards, maybe. Like maybe, let me think how you're going to have to do. So some scientific. Maybe I better write scientific. Some of you will have to do it this way. 150, and I think you all have the x squared key. Is that right? 150 squared plus 35 squared minus 2 times 150 times 35 times, and I think some of you might have to put in 110 cosine, and I'm hoping that works right. And then equals, and you may have to push equals again. I can't remember. And then whatever you get, then put the square root. Does anybody have to do it that way? Yeah. On yours? Yeah, I thought yours might be that way. I wasn't sure. Did you have to push equals twice to get it to total everything?
No, it does the cosine automatically for me.
As soon as you put the cosine after the 110, it does that part, and then you can total everything, and then you can hit square root on whatever's on the screen,
yeah,
and it'll give you the answer automatically. You don't have to push equals again, right? Okay. Everybody getting it okay on your calculator there? That's part of it on these, I guess, is figuring out how to make it work out right with the technology too. All right. They also give you some problems in here where you have to draw out the triangle yourself. Let's do one of those just to kind of get started with it, and we'll see on it how to use the law of sines on it as well, so we can mix it up a little. But over on, still on page 532, I'm going to look at number 18 there. A is 2, C is 1, B is 10 degrees. That's what they tell us. We're drawing our own picture. We have ABC. Angle B is 10 degrees. Side A is 2. Side C is 1. So first we will find what? Well, the law of cosines is set up pretty well for us to find that missing side first, that side B. So we'll go with the B squared equals A squared plus C squared minus 2AC cosine angle B. Okay, we'll use that form of the law of cosines here. That'll be B squared equals 2 squared plus 1 squared minus 2 times 1 cosine 10 degrees. So you're going to use what we just talked about to get what that is. I'm going to write up here that's 4 plus 1 minus 4 cosine 10 degrees. 5 minus 4 cosine 10 degrees. That's for B squared, though, still. Somewhere I got to take the square root of that. So what's side B here?
So 1.03.
So 1.03. In the textbook, they say at the bottom of page 529, what I was telling you about using that smaller side, if you're going to find the law of sine or use the law of sines now, at the very bottom of page 529 in your book, it says the law of sines can be used if the angle sought is opposite the smaller side. With that in mind, which angle would we look for here? If we're going to use the law of sines to do it. Which one?
C.
C. Right, C will be the smaller angle. So we can use, I'll put can. You can still go with the law of cosines, though, just to be on the safe side, but can use law of sines if you find smaller angle first. Okay, and that makes it work out correctly. It's where it's not dealing with the ambiguity that can result. So we would have the sine of 10 degrees, because some of you might like to resort back to this. Sine of 10 degrees over 1.03 equals the sine of angle C over 1. So 1.03 sine C equals sine 10 degrees. Divide by the 1.03. And angle C is going to be the inverse sine of the sine of 10 degrees over 1.03. And you all can see what that calculates to be. What was it again? Tell me again. 9.71. Okay. We have agreement. I see some agreement, some nods. That's good. Okay. So angle C would be 9.71 degrees. This is a very small triangle, isn't it? And then, though, what is angle A going to be?
160.29.
Okay, 160.29 degrees, because you took 180 degrees minus, you added together the 10 and the 9.71 to get 19.71 degrees, and that left you with 160.29 degrees. Now this triangle, it must have a really large obtuse angle there, that 160.29, and it's almost flattened out. If we were really looking at that, you know, it's really going to be, I don't know if I can even draw it. Let's see. It's going to be pretty flattened out. It doesn't cross like that. I just can't draw. Okay, something like that, but it's going to be kind of smashed pretty flat. They have some in the book like that are drawn out pretty smashed down. Does anybody have a question on this one here? I just wanted to show you can use the law of sines, but use, you know, we're talking about using that smaller angle. You can't use the law of sines until you've already used the law of cosines for something. You'll have to start out with the law of cosines, but then you can resort to that law of sines as long as you find the smaller angle first. Okay, go with the smaller angle, or else you can get things that don't work. Okay, let me give you some of these to practice with before Thursday. Plus, you've got those My Math Lab quizzes. Don't forget about those things. Over on page 532, this is in 8.3. Let's work over there with just 9 to 43 odd, and then 49 for now. It has several parts on 49 for you. And I don't know, maybe you all would also like, let's see what else you might like. Number 47. I should have put that before 49, but that's all right. We'll throw that one in there too. Okay, for now. See what you can do with those, just to kind of, as you're working on these, keep straight in your mind, you know, we've got the right triangle trig, we've done the two things for the oblique triangles, the law of sines and law of cosines, try to distinguish between those. We'll move on next time and see where we are with the triangles, okay? You all have a great day today.